Okay, everyone, since this is a video, I can go through things relatively quick and you can pause as needed. Let's start off with this situation here. You have an engineer. Engineer has been told that he needs to design a road that will be able to withstand the loads not only today, but 20 years later. And now that has presented a problem for him because he doesn't really know how to go about that. He does know that when he builds a new road, everything is good. Thumbs up. But sometimes we find when time passes, 20 years down the line, the roads can end up in very bad condition. And it's probably because they didn't have the correct loads calculated for 20 years down the line. What he really wants is for the roads to be great at the very beginning, but also he wants it to be good 20 years later. So you can have that same smiling face. So what we have to do is eventually come up with something called the equivalent single axle load, which would allow us to determine what the load would be placed or what load would be placed onto the road 20 years, 30 years, 40, 10, however many years down the line. And when we do that, we have a proper load that we're calculating for, and therefore less of a chance for that to occur. So what he really needs is this equation. This equation will allow him to be able to determine what the loads would be on the road 20 years later or whatever that period is. Now I've already kind of gone through this in the past for you, but we'll just kind of step through each one of these variables really quickly. So the first variable right there is the ith vehicle. So you can see I have a high here for each one of these, or I guess the vehicle type. So if you have a bus, then you'll calculate the ESAL for a bus. If you have a truck with just two single axles, then you'll calculate the ESAL for that type of truck. If you have a truck with maybe three single axles, then you'll do it again for that type of vehicle. And then in the end, you just take the summation of all of them. You have the load equivalency factors, which can be found from tables. You also have the design lane factor that can be given or can be determined. You have the average annual daily traffic that must be given or determined. And then finally, you have your growth rate, which can be calculated or found from the tables. And if it's calculated, that is the calculation that you're going to be using. So I've arranged my variables in this way for a reason. First of all, if you wanted to know what the ESAL was just for, let's just say, one day, then you would just use this section of that equation. If you wanted to know what the ESAL was for an entire year, then you would use this section for the end of the equation. If you wanted to know what the ESAL was 40 years, 30 years down the line, then you would need to use the entire equation here. To determine what the load would be that far into the future. And if you have the correct load, then you can properly design for the roadway. So for instance, you can be given this information. Circled in green, you see that it says during the first year of service, the following is observed. The following meaning everything down here circled in green. But the question is, what is the ESAL for the first year and the ESAL for the road after 20 years of service? And it tells you some other things like assume an annual growth rate of 4%, a design factor of 0.45. Hopefully you already know what those things are from that equation. So if this was given, we should be able to determine what the ESAL is. So let's take a look at what was given. So we have different vehicle types. So you got a single unit trucks, and each one of these single unit trucks has a different makeup. And then you have a tractor and semi and combinations, and they have a different makeup as far as their axles are concerned. You have the number of these types of vehicles, and you also have the truck factor. Okay, the truck factor. So if you have the number and you know what each one of these types of vehicles places on the road in terms of 18 kilopounds, then by multiplying it, then you would know what all of these vehicles on the road, all these types of vehicles places on the road in terms of 18 kip pounds. Because that's all a truck factor is. It's the 18 kip load that is felt by the road by that vehicle. So part of the solution is already shown here. All right. When we take the product of the number of vehicles and the truck factor for that specific vehicle, we end up with the load representing 18 kips for those vehicles all the way down. And when we take the summation of them, we end up with 61,590. But the question asks, what is the ESAL for the first year? This really only gives you this only gives you half of the equation, or half the answer. You see, if I were to write down my ESAL equation again, I will be able to represent what this is within this equation. See, this number is represented by the first 4 items in this equation: 61,590. And if I wanted to know what the ESAL is for the first year, then I would also have to include what the design factor is. It's 0.45, or 45% of the vehicles are traveling in the design lane. That's another way of saying that. So when I multiply it by 0.45, the ESAL that I get for year 1 is equal to 27,715.5. Okay. Again, it is decreased because we're only looking at one lane here. This is the design lane. So only 45% of the traffic, so 45% of what that ESAL is. Now, if I wanted it for 20 years, which is what the question asks for, then now I need to incorporate everything here. All right. So let me just go ahead and change colors. Now for 20 years, I now need to incorporate this entire equation. All right. For 1 year, all I needed was this part of the equation. So for 20 years, let me just go ahead and take the 61,590 times 0.45, and then I need to multiply it by my growth rate, my GRN. And if you remember in the past, we kind of went over the growth rate equation. I'll just put it off to the side here so that you can see it. The growth rate is going to be equal to 1 plus 0.04 and this is raised to 20 minus 1, and all of that divided by 0.04. The 0.04 is coming from what was given in the example problem, so 4% growth rate. When you calculate all of this out, this actually turns that number, or that variable, into 29.78. So in 20 years, there'll be 29.78 more vehicles on the road. And in the end, what that means for the ESAL, and I'll just kind of write down the answer over here, for 20 years is equal to 205,365.6. and that is how many 18 kip loads, which is essentially what an ESAL is.